We now understand the periodic table with greater depth, seeing how electron configurations are the factor that dictates the table's organization. From the table, we can also learn about a number of other trends. The first we will look at has to do with the size of an atom, or the atomic radius. It's difficult to measure the radius of a lone atom, so the convention is to tabulate lists of covalent radii, which are defined as 1/2 the distance between the nuclei of two identical atoms that are bonded to each other. This should be roughly the same as the radius of the atom outside of the context of a chemical bond as well. When we examine various covalent radii, we notice that the radius will increase as we go down the periodic table. Take the list of the halogens. There is a clear increase in radius with each halogen. This is because when we go down a row on the table, we are increasing the n value by 1, thus adding a shell and placing the valence electrons farther away from the nucleus. This makes the atom larger, as well as its covalent radius. This trend is without exception. But what about moving horizontally on the table? Generally, as we move to the right along a period, the covalent radius will decrease slightly. This may seem counterintuitive, as the addition of electrons doesn't seem like it should result in a smaller radius. But we must realize that as we move to the right, we are also adding protons. And the more protons there are in the nucleus, the greater the electromagnetic attraction that will pull the electrons in the existing shells a bit closer to the nucleus. There are a few deviations to this trend, particularly if we were to examine the transition elements of a particular period. But in general, atomic radius will decrease as we move through a period. We can look at a version of the periodic table with radii illustrated to get a better sense of this parameter. Any electron in an atom will experience a particular effective nuclear charge, symbolized with a Z. This is the pull exerted by the nucleus on a particular electron of interest. The inner or core electrons shield the valence electrons from the pull of the nucleus, so Z effective will be Z, or the number of protons, minus the shielding or core electrons. So it's as though each core electron cancels out one proton to tell us the effective charge that is attracting the valence electrons to the nucleus. Valence electrons do not shield as well as core electrons do, which is why Z effective increases as we move to the right along a period, which results in a contraction of the covalent radius. Looking again at all the elements at once, we should be able to slightly enhance our understanding of the periodic table.